Morning.
Morning. I think today will be our second bi-weekly seminar. Thank you so much for everyone joining us today. I think we will start recording this seminar. If you don't mind, Sarah, you can start. Okay. Today there will be two presentations. The first one is from a team. Hold on. From Alex, RunRun, and Shuyi. They are working with Terasaki Institute for Biomedical Innovation. So let's introduce our partners from Terasaki. Nathan.
Hi, I'm Nathan. I'm a Terasaki fellow here at Terasaki Institute. And most of my work is on tissue engineering. And I have a lot of interest on cancer models.
Thank you.
Nice to meet you.
Nice to meet you, yeah. Nathan is, right now he's the Terasaki's fellow, and then he's the expert in the 3D bioprinting, the tissue engineer, and he has been guiding our students from CSUN a lot, like the RunRun, Alex, and the Shuyi, and then we also have another 3 students was working in Terasaki, especially during the pandemic area. Terasaki is one of the nonprofit organizations located in West LA. It was founded by Professor Paul Terasaki, and the ARCS, our Autonomy Research Center, and for STEAM, we established the strategic partnership with Terasaki last year. We signed up the MOU agreements, and right now our students, they can work with this really excellent and cutting edge research institutes in the West LA. I think that provide a lot of opportunities for our students. And another most exciting news I'm going to share is Terasaki right now is working on another new building in Woodland Hills that will be closer to CSUN. I think whenever they open this new facility in maybe in the second half year of 2020, and then that will be more convenient for us, and then we will have more collaborations on the biomedical application, the bioengineer research. Thank you so much, Nathan. Yeah, for supporting our CSUN students.
It's my pleasure always.
Thank you. Newt, do you have anything to add?
Well, I just want to say a very warm welcome to everybody attending today my weekly seminars, and it's great to see many of you, and there's going to be lots of good insights about our research today and also in the next couple of weeks. But again, I'm here just to provide moral, emotional, and financial support. I'm really happy to see many of you, and I'll turn it over to Bingbing.
Thank you, Newt. Yeah. Next, I think we will have our first presentation. This is the team of Alex, RunRun, and Shuyi. You can introduce yourself a little bit, and then you can start your presentation. Sounds great.
Yeah. Hello, everyone. My name is Alejandro, or I go by Alex, and I'm the ARCS fellow from last year, continuing my fellowship this year.
Thank you. RunRun.
Hello guys, my name is RunRun, and I'm a senior student in mechanical engineering.
Hello everyone, my name is Shuyi Huang, and my major is nutrition and dietetics. And for now, I just in the ARCS associate for this year's.
All right, gonna go ahead and get started. Oh, excuse me. All right, so our project is titled 3-Dimensional Bioprinting of Pancreatic Cancer Stromal Organotypic Microtumors. Give me a second. It's a helicopter passing by. Okay, so for the basis of our research, pancreatic cancer is a type of cancer that starts in the pancreas, with pancreatic adenocarcinoma being the most common type of this cancer. In efforts to capture pathopsychological characteristics of human tumors, in vitro models are essential for basic translational cancer biology. However, current in vitro cancer models lack the native microenvironment where cancer stromal communications and cellular migration take place within the extracellular matrix. Our research team promotes an effort in the innovation of bioprinting three-dimensional cancer stromal tumor models for preclinical drug development, personalized drug delivery, and complex biological research. So we aim to do so by 3D bioprinting organotypic microtumors by innovating a bioink, which will encapsulate our tumor cells and our fibroblasts, from which we will combine into a cartridge and bioprint some samples in which the cells will self-assemble and form an organotypic microtumor. So first we started off by engineering a bioink. In engineering a bioink, we wanted it to meet 4 criteria. The first one, for it to be biocompatible, be UV cross-linkable, possess shear thinning properties, and be thermally stable. 2 compositions of our bioink that we chose were Gelma and Laponite. Gelma has been known to be biocompatible and UV cross-linkable, whereas Laponite has been known to possess shear thinning properties and be thermally stable. So from here, we created 8 concentrations of our biomaterials ink. Here we divided them into 2 different categories, one of them being 10% Gelma and the other one being 5% Gelma. 10% Gelma is typically alone printable at, not at room temperature, but it's printable without any fillers. However, is not printable at room temperature. Also, 5% Gelma is not printable at room temperature and it does not hold the structure. So this is why we chose Laponite as a filler to provide our Gelma more physical properties. So first we started off by comparing the printability of each concentration. So as you can see here, we have the group of 5% Gelma with its respective Laponite concentration. And here we have 10% Gelma with its respective Laponite concentration. As you can see here in our 5% Gelma, the printed fiber is more consistent, but it's thicker than 10% Gelma. Although being consistent is good, it's also very important for the fiber to be true to its diameter size. As you can see here, we were able to calculate the fiber diameter ratio in which 5% Gelma was 4 times greater than the diameter size, whereas 10% Gelma with its respective Laponite concentration was about 3 times greater than its diameter and also size. All right, so now Shuyi, gonna go ahead and talk about injection force and rheological characterizations.
Okay. In the figure 3, we mainly focus on the data of the injection force and the rheological characterization. Now I will explain the result diagram of the part A and B in figure 3. First of all, part A in figure 3, the curves of the injection force from the Gelma and the Laponite composite bioink using a 30G PTFE nozzle per 3 centimeter cube syringe combination, and the quantification of the injection force plateau volume from the Gelma and the Laponite composite bioinks. We analyzed the mechanical properties of the Gelma and the Laponite composite hydrogel before and after UV cross-link. First, a syringe loaded with a composite hydrogel that is not UV cross-linked was set up as shown in figure 3A to measure the injection force. In general, bioinks with improved injection force are preferred due to their high viscosity and shape friendly that can improve the 3D bioprinting outcomes. On the figure 3 part A, number 1 and 2, the composite bioink group, which is G5L0, G5L2.5, G5L3.0, and G5L3.5 containing 5% Gelma show a 30G PTFE nozzle per 3 centimeter cubic combination even at a higher concentration of the leptonides. For the leptonides, which is a 3.5% weight per volume, according to the injectability evaluation. Interestingly, the mixment force required to inject the composite hydrogel G5L 3.5 through the string was observed to be about 6.7 Newton. The use of this composition demonstrates that is a bioprinting process can be challenging due to the lower viscosity. Of the figure 3 part A, number 3 and 4, we also test on any other set of the composite hydrogels containing 10% drama and the lower concentration of leptonides. The group is G time L0, G time L10, 1.0, G10L 1.5, and G time L 2.0. So as expected, even at lower leptonide concentrations, about 1%, 1.5%, and 2%, the composite hydrogel containing 10% drama and higher injection force compared to the G5L 3.5 composite hydrogel gel. Although showing different in injection force, we observe that all drama leptonide composition will successfully extrude through a 30G PTFE nozzle per 3 cc. So for the 3T PTFE syringe combination at a rate of the 0.55 millimeter per second. Increasing plateau injection force curve with the no logging or non-uniform change was showing irrespective of the composition of the hydrogel. Suggesting that all composite bio-ink exhamptate is like showing a homogeneous quality. For the part B, figure 3, we also evaluate the sharing thinning properties of the JAMA and the leptonized composite hydrogels to investigate whether the composed hydrogel improve the rheological property over the JAMA hydrogels. So for this result show that this rheological characteristics of our composite hydrogel are known to due to the ionic leptonized interaction, in addition to the JAMA leptonized non-covalent surface interactions. Please move on to the next slide, please. So for the figure 4 is photo crossing link, rheological and the mechanic compression and microscopic characterization of the JAMA and the leptonized. In this study, we applied dynamic rheological to study the cross-link reaction of the JAMA as a function of the time with the contained oscillation frequency, as shown in part A in the figure 4. So for the figure of the C and D are the JAMA and the leptonized composite bio-ink sample was irradiated throughout of the experience. As a cross-linking reaction process, the storage modules increased indicating increase in like stiffness. The reaction rates decreased about the 2 minutes of the cross-linking reactions, as shown by the decrease in the slope of the G1 curve. So for the JAMA, 5% about the 72 second, and the JAMA 10% about the 132%, 132 second. The directs in the rate of the described as the degrade in the number of the available or model unreacted group as the cross-linking reaction. So finally, the microstructure of the JAMA and the lipids composite hydrogels was evaluated to review if change in the bioink composition affect the structure of the final hydrogel scaffold. The microstructure of the composite hydrogels was associated using the SEM after freezing drying. And the figure F, it is to show the degradability of the JAMA and the lipid composite hydrogel scaffold result. So next, move on to the RunRun.
Thank you, Shuyi. Okay, so as liponide-based hydrogel is comparable to lymphocyte microenvironment, which facilitates the germinal center-like response. Therefore, we analyze the effects of JAMA and liponide composites on cell fate, morphology, proliferation, and aggregation in a 3D bioprinted tumor model. So here we study in vitro biocompatibility of cell-laden JAMA liponide composite hydrogels and the morphology of the encapsulated pancreatic carcinoma cell line. On the right-hand side, you can find the figure A and figure B are showing the life or death cell fluorescence image of Mia Paca, which are the cancer cells here. They were cultured from day 1 to day 7 for checking the cell viability and the metabolic activity. The alive Mia Paca 2 cells are stained in green fluorescence, and you can observe here the 10%. The 10% JAMA has more alive cells compared with the 5% JAMA. And figure C and D exhibits the quantitative analysis of the 5% JAMA and the 10% JAMA, and the results accommodate the observation from the figure A and B. In figure E, the Mia Paca cells are encapsulated in JAMA liponide composites, and the 3D bioprinted microtumors were cultured for up to 14 days. When there's only JAMA, the cells tend to migrate to the surface of the microtumors. When liponide is introduced, the cells are prone to aggregate within the microtumor. And there is a significant aggregation in the JAMA that has high liponide ratio. Please go to the next slide. Thank you. Here's cancer-associated fibroblasts, we also call it CAF, play an important role as a unique microenvironment to pancreatic cancer cell, which influence the cell aggregation, proliferation, invasion, and resistance to therapeutic. Therefore, it is essential to develop an in vitro 3D tumor model that reflects the cancer biology. Now we could culture Mia Paca 2 and the fibroblasts into the JAMA liponide composites. On figure A and B, it's showing the JAMA 10% JAMA liponide bioinks mixed with the Mia Paca and the fibroblasts in 1:1 ratio. Then we 3D bioprinted into the 48 wall plate. And on figure C, cells are stained in green and doesn't, on figure C, we analyze the cell distribution over time up to day 7 in the 3D bioprinted microtumor. And the tumor cells are in green and the fibroblast cells are in red. When the JAMA has no laponite. Both cells are evenly distributed through day 1 to day 7, but when laponite introduced into the 3D model, the fibroblasts aggregate from day 1 throughout the experimental period. The increased concentration of laponite increased the aggregation, especially starts from JAMA 10 laponite 1.5. The aggregation become more prominent. Next slide,
Just
please.
a friendly reminder, you only have 5 more minutes.
Okay. In order to elucidate the bioactive properties of the laponite in detail, we perform the gene expression of the mRNA by culturing the multicellular 3D bioprinted pancreatic tumor using the JAMA laponite composite. So on the right-hand side, figure A and C are showing the gene expression analysis. The red area indicates the upregulation of the gene expression, whereas the blue areas indicates the gene expression of downregulation. Specifically for 10% JAMA laponite 1.5 group, we can observe that the tumor growth factors upregulated, and also all the genes expression upregulated, yes, for that group. And the B and D showing the quantitative analysis for the complementary study for gene expression. And on figure C, it's showing the mouse cat relative gene expression level analysis. And you can see here the gene expression upregulated significantly starts from the G10 laponite 1.5 group. And from here, I'll pass it on to Alex to conclude.
Yes. Give me a second. So I'd like to acknowledge our team that collaborated with us. I'd like to acknowledge ARCS. I'd like to acknowledge the professor at CSUN, Dr. Kelber, and our team at Terasaki Institute. And then also our associate part of LSAM. And that's pretty much it. Is there any questions?
Thank you so much for this excellent presentation. Before you raise up any questions or comments, can you change your name, your screen name, to include your name and then your organization like ARCS? You can see like a Steven, right? And then he put the ARCS as the organization. Thank you. Any questions in the comments from Zoom and also from ARCS, the headquarters? Any questions? Comments? Sure.
Can I just say that they did a wonderful presentation? You guys are very thorough and you'll explain everything so well. And it's a great research project. And I can't wait to see how much you've completed at the end of the year. So great job, everyone.
Thank you.
Any other comments? Question? Any questions or comments from Zoom?
So I have a question for one of the who presented. So based on the results you presented, the conclusions, you developed a 3D bioink or 3D bioprinting of a tumor and fibroblast cells. So what would be the best application for this material?
The best application for this material would be possibly, as we mentioned, like drug delivery or possibly personalized drug screening, where here we're able to find some gene expression of some gene expression of some related genes that will help us like target therapeutic drugs and stuff like that. Yeah.
Okay, so basically you have a gel that can be used to model cancer, to model tumors. And then after you develop those tumor models, so then they can be used for drug screening or to study the biology of tumors.
Yes, that's what our aim was, to do that.
Okay, thank you.
Mhm.
Thank you so much. Any other comments, questions? Okay, thank you. Thank you again for Alex, RunRun, and Shuyi's great presentation. So next will be Samira, Angelina, and the HARCS Association, right? Their topic will be holistic eco-cultural avenues of research and treatments through the technological solutions. And the faculty advisor is Kevin. So let's invite Kevin to, hi, Kevin.
Hello, everybody. Welcome. Nice to see all those faces and see folks in the space and the beautiful pup there as well. I am really pleased to be introducing this team today. This is a project in collaboration with Medtronic, looking at certain types of health disparities that occur in the management of type 2 diabetes from an anthropological perspective. And what's special about this presentation today is that we've been at this for a while. When you do research with human subjects, there are a lot of potential snags in achieving and acquiring the permission from your human subjects committee. And so we've been on this thing for some time. Samira and Angel have put in a lot of work and done a fantastic job, but not least of which was developing our associates into, partners on this project. And we have quite a few partners, but 3 of them today are going to be doing the presentation. So this is in the spirit of showing all of the new fellows and associates what we envision the role of associates being, which is an active participant in the research. And even if you're not receiving the fellowship, this sort of experience can help propel you to the next level and to the next thing. I'm going to leave all of the rest of the explanation to our wonderful presenters today, Meg Thorne, Stephen Mejorado, and Elizabeth Bedrosian. So I will turn it over to them.
Thank you, Kevin. Do we have any partners from Medtronic or the HARCS today? We can introduce them and acknowledge them.
I don't know if we do.
I checked the participants. I didn't see Dr. Rebecca or Chia.
I did not see Dr. Gottlieb here, so I
Okay.
or
Thank
I
you.
would have made mention, but
just to confirm. Thank you.
sure.
Yeah, you can start.
Okay. Our study explored the ways in which individuals make decisions about the management of their type 2 diabetes diagnosis and associated comorbidities, beginning from the premise that type 2 diabetes is a disease of multifactorial origin. More specifically, we aim to look at how type 2 diabetes and its associated comorbidities impact the Latinx population. Our study participants were drawn from the Latinx population in our extended CSUN community. With an ethnographic qualitative approach, we interviewed type 2 diabetes patients and their family members using the methodology known as ecocultural family interview. EFI allowed us to use the household as the unit of observation and the person with diabetes as the unit of analysis. Under the backdrop of a critical medical anthropological approach, we intend to contribute to an existing body of literature, which addresses patients' lived experiences from within the political economies they inhabit, with an emphasis on the role of larger socioeconomic macro processes. Ultimately, after all is said and done, we plan to inform future avenues of research for ARCS and the creation of a socio-technological tool for aiding the treatment of type 2 diabetes and associated comorbidities, specifically for the Latinx community.
Our project is titled Holistic Ecocultural Avenues of Research and Treatment Through Technological Solutions, or HARTS for type 2 diabetes. Before we introduce our research project more fully, we would like to give an overview of the amazing team we've had over the past few semesters. Currently, our team is composed of students from several different fields and areas of education. The research fellows for this project are Angelina Geisen, a psychology undergraduate, Samira Rashti, an anthropology graduate student. The associates on this project consist of Elizabeth Bedrosian, a pre-med psychology student, Jasmine Campos, a psychology student, Emerson Martinez Godoy, a psychology student, Stephen Mejorado, a mechanical engineering student from College of the Canyons, and I am Margaret Thorne, a pre-med anthropology student. Half of our associates are bilingual in English and Spanish, and aided in the interview process for the comfort of our research participants. It is important to our research that we are able to communicate with bilingual interviewers because we are inspired by the Promotoris model that aims to use people from the communities themselves to help disseminate information, education, and opportunities to the wider community in culturally compassionate ways.
So to briefly go over the timeline that we've had for the project so far, from the start in June, we compiled many annotations and created a 20-page literature review document for Medtronic, which was also formally presented to Dr. Rebecca Gottlieb in early June. And throughout this time, we also worked on developing and submitting the Irb protocol, which after originally submitting in May, we had received the Irb approval in mid-July. During the outreach process to recruit participants, we set time slots up for our interviews. And as we did this, we learned and practiced how to code, since this would be something we needed for our future use. We began the interviews in October and are currently working on finishing the last few scheduled interviews in the next 2 weeks. As such, we are engaged in the data collection process, and we are also engaged in the initial construction of our code book. Our final deliverable to Medtronic is on track to hopefully finish by the end of this month.
The household was our unit of observation for this study. We define the household as either an individual person or group of persons who live together in the same housing arrangement and work together to provide themselves with food and other essentials of living. The household can provide a lens into the greater macro level processes and daily decision-making that affects people's experiences with illness and disease. Moving through the icons here, we have dietary choices in relation to food deserts, exercise habits in relation to security and safety within a neighborhood, and lastly, frequency of doctor visits within socioeconomic status and additional economic pressures. An important note, the micro level of individual choice is often heavily influenced by the macro level socioeconomic circumstances. Through our interviews, we aim to ascertain the shared experiences of this community, both on a micro and macro level. We hope that this knowledge can inform Medtronic's understanding of the root systemic barriers that communities of color face in America, so they can better address those needs through the development of their socio-technological device.
Before moving on to our methods, I will elaborate a bit on a specific theoretical framework guiding our research, critical medical anthropology, or CMA. As its name denotes, CMA critically examines the field of medical anthropology and biomedicine as it exists within a Western hegemonic global setting. To be CMA-oriented is to acknowledge the role that medical anthropologists play in legitimizing Western biomedical approaches to medicine and the many nuanced ways that histories and current realities of racism, imperialism, colonialism, and globalization affect our constructions of healing, illness, disease, and more. As our study will be addressing the management of this disease among Latinx populations, we expect that some percentage of our study population will be living on the margins of mainstream society with regard to immigration or socioeconomic status. A community that has been very profoundly been affected by these greater structural violences. CMA also offers insight into the often unequal social relations that inform the health experience for individuals, communities, and even nations. For example, consider the status that doctors hold within society in relation to a person who is their patient. Whose concerns, whose words, whose final decisions hold more weight? This interrogation of power arrangements and structural inequality that accompanies CMA will provide the backdrop for a comprehensive analysis of other theoretical orientations through which to explore the health management strategies of our research participants. For those that aren't familiar with anthropology, I would like to provide an overview of traditional anthropological research, which is primarily centered in ethnography, a method of research and data generation, which utilizes a variety of tools and such as participant observation, interviews, focus groups, and other qualitative methods. In academia, ethnographic research typically requires a year of deep hanging out to generate data, where researchers go and fully integrate themselves into a culture for many months. In applied settings such as ours, this hanging out time has to be shortened and fewer methods are employed. We have chosen to employ the semi-structured interview as our preferred ethnographic tool because it allows for a more nuanced response from participants, which in turn meets our methodological goal of recognizing the social, cultural, and historical context that is integral to our understanding of type 2 diabetes and comorbidities as experienced by the Latinx community. The COVID-19 pandemic has introduced an element to research that is unprecedented. For the majority of the past 2 years, any research that was considered non-essential was not allowed to be conducted in person. Because of this traditional ethnographic research, the hanging out that anthropologists engage in has become increasingly difficult. To mitigate this issue, we have decided upon data collection methods that can be conducted safely in an online environment. Apart from the semi-structured interview, which we just mentioned, we will be discussing our other methods, including illness narratives, eco-cultural family interviews, and grounded theory in their own slides. It should be noted that any methods we employ actively aim to disengage the hegemonic roles present in traditional ethnographic research. We do this by encouraging multivocality, or the inclusion of multiple voices or perspectives in a way that subverts the traditional hierarchy between a singular powerful author and a passive audience or reader. As researchers, we will engage with this methodological practice throughout the interviews by speaking with multiple household members and letting their interpretations and narratives guide our understanding. Moving forward with our methods, central to research in medical anthropology is the collection of illness narratives. This is a concept defined by anthropologist Arthur Clayman, but it has been adopted by many psychology researchers. It is a methodology in which researchers pay close attention to how individuals make sense of their illness through their own personal narrative. They provide a window into how people negotiate the meanings of an illness, explain their suffering to other people, and use their narrative to make sense out of what is happening to them. By extracting themes from the illness narratives, researchers have been able to gain a glimpse into the ways that narratives about diabetes function as an expression of social suffering and emotional distress, and create a more comprehensive picture of the diabetes experience within the Latinx community. And we hope to follow this model as well by interviewing patients on their own narratives.
So as mentioned, we use the eco-cultural family interview for our ethnographic approach. It is a highly adaptable conversation-like interview that is focused on open-ended questions rather than the simple yes and no responses. It allowed us to interview all adult family members of a given household to gain a more holistic and nuanced view of the daily routines and patterns that occurred within the home. It also highlighted the aspects and experiences in the day that mattered most to the research participants, which allowed for our study to identify the specific needs at the level of the household related to the management of type 2 diabetes. Placed upon areas of attention within ethnographic work are integral to illness narrative data collection methods. At its core, EFI places an emphasis on the discovery of locally rational action and allows for participants to speak about their day and discuss where they found the meaning, value, or concerns. This was important as it allowed us to identify the direct and specific ways where intervention may be needed to better support our study population in their management of type 2 diabetes.
Finally, I would like to go over the grounded theory research method. Grounded theory is a group of inductive coding methods used to perform preliminary research, ideal for the generation of models and hypotheses. It is utilized by identifying recurring categories and concepts that emerge from texts and interviews. We call these codes, and they are used to inform an initial codebook, which is a list of definitions and categories. Then concepts are linked with substantial theories and conclusions, and the themes in the codebook inform the construction of theoretical models to explain the findings. To illustrate this approach further, we have these two little triangles to illustrate how this approach starts off very different from the quantitative approach to research many of us are used to seeing. In traditional research, we start with our theories. From there, we create our research design and begin our hypothesis testing. A hypothesis is developed prior to data generated, as it is a deductive approach to research. In a grounded theory approach, we start with gathering data in an inductive research method. After the data is generated, we code it or put them together into themes, and then we start to generate theories and hypotheses based upon our data. Our methods are all about studying how dynamic phenomena operate in context and how individuals handle type 2 diabetes in the context of their own environments.
At this point, our team has been conducting interviews for a couple months. As we move through this data and begin to establish our initial codebook, we have identified certain themes that we would like to discuss here. For example, traditional notions of women's work and the emotional labor that often comes with that have been present in several interviews. At the level of the household, we are finding, with very little exception, that women take on a majority of household chores, in addition to the management of type 2 diabetes, regardless of the sex of the patient.
Another theme is tension between the lived experiences of our respondents and the Western biomedical compliance model for healthy living. Recommendations by physicians to exercise, for example, has become problematized by concerns about the security of the neighborhood. There was one woman who described it as, "My dad loves to walk, but we don't let him go too far because it's just not safe. We hear gunshots all the time." Shame is another complex theme that has emerged in our interviews. At times, it is related to physical ability and gender expectations. As one respondent spoke of her father's sadness at not being able to physically work and provide for his family. At other times, shame appeared to be related to a sense of self-discipline and non-compliance with expectations for healthy food and alcohol choice.
The lack of healthy food choices in one's neighborhood has also emerged as a common theme in our initial review of the data, which can combine with socioeconomic limitations, such as the lack of reliable transportation that is needed to procure something other than fast food options. Finally, the theme of cultural brokering has been prevalent. Family members discuss having to translate for patients, which often involves learning an entirely new vocabulary in Spanish to reflect complicated medical terminology. These family members are doing the work of actual medical anthropologists and have noted a clear need for more attentiveness on the part of medical professionals to the problem of translating information from one register to another. This is a small sampling of what we're beginning to see in the data. As we work to complete our interviews in the next 2 weeks, we look forward to the final analysis that will follow. We hope to provide a comprehensive report of our findings to Medtronic by the end of April.
Awesome. Thank you guys for listening to our presentation. And if anybody has any questions, this would be the time to ask.
First of all, great job from our associates. I'm really pleased. I think that you have really grasped all of this material in a very sophisticated way, just as our research fellows have. So just outstanding, really good work. And we open it up to questions.
Thank you. Thank you so much for your great presentation. Excellent job. Do we have any questions from crowd space? Comments? Sure.
Great job, guys. It was very thorough, to the point. And you explained everything so well, and all of your research is going to be like very impactful. So thank you and good luck on finishing up your projects.
Thank you.
Bingbing. Yeah, hi, Bingbing. I just have a quick question here. Can you hear me okay?
Yep.
Okay, perfect. First of all, thank you so much for giving this awesome presentation. I just have one quick question here. First of all, I'm not in this area. I just be curious, how do you distinguish your approach or methodology compare with the existing research? Just be curious, what's the status of the existing research? How do you differentiate yours versus the existing ones?
Samira or Angel, if you want to think about that, I'll start out. What's unique about this project is the employment of looking at things at the level of the household, for one. So this provides a sort of wider look at the experience of type 2 diabetes that, even if without COVID, even without the restrictions, it would not be possible for us to go in and spend that much time in each household. And so getting this comprehensive view of the household is really something special. I don't know if you've had this experience, but many folks talk about, and I know I've had it with my mother and helping her address her cancer, and I would take her to doctor visits. And I know what's happening with her. When we get to the doctor and she's been in pain and this, and then we get to the doctor, how are you doing? Oh, I'm fine, right? So getting a more comprehensive picture of the illness and hearing the different illness narratives at the level of the household is, in terms of methodology, really makes this a unique project for us.
Thank you.
Mm-hmm.
Any other questions or comments?
Another question.
Great.
Where are you guys conducting how are you guys conducting the interviews? Like, are you guys going to people's houses and asking the questions, or being invited?
All of the interviews are conducted over Zoom. So like it was mentioned in the presentation, because of the COVID-19 pandemic, there are strict IRB regulations as to what is allowed. The IRB is the Institutional Review Board that anyone who is doing human subjects research needs to get approval from in order to conduct their research. So we aren't, there are very strict regulations about doing any sort of in-person research and interviews for the past 2 years. It is starting to be more open and flexible now. But yeah, we were not able to do any of that for the past year's work. So all of the interviews happened over Zoom.
Cool, thank you.
Thank you. Any other questions?
I want to encourage all of the ARCS fellows and students in the room to take advantage of the activities that bring the ARCS community together. Following the brilliant presentation that preceded ours was difficult for me, right? It's not my training. And so it's really useful. And I understand that some of the things that our students discussed might also feel a little bit weird. It's not what you study. So that is the purpose of this thing, is to the interdisciplinary, the convergence of all these disciplines. And I encourage you to talk, even outside of this meeting today, attend the social events, talk to Samira and Angel and Stephen and Elizabeth and Meg, and let's get some, cross-cultural contamination going, right? Let's learn about each other's stuff. Sometimes we feel shy to ask a question when we don't understand a lot about what's going on. But if I had any of those first students alone, I would take them aside and ask those questions, right? So I encourage you all to take advantage of the social events.
Thank you, Kevin. Any comments from Casey? I saw you are here. Casey or Max?
I have a comment. I think it's in line with Kevin. For the presenters today, especially people working with me, I want to say that it's very important when we understand the people we are presenting to. For example, if the people you are presenting, they are not in the same area or they are not scientists at all, it's very difficult for them to understand what we are talking about. So as Kevin said, it's very important to go and explain your work to other people, and then you get used to explain using simple words that everyone can understand. It's very difficult when you use words that people even don't know the meaning. So if you use simple words, and if you are able to explain to your friends, to your family, And if they understand what you are talking about, so everyone will understand. So
that's a good
keep
point,
practicing.
Nathan. That's a good point. You know, I created a template for all of the ARCS fellows, and it's still out there. And it's a really quick and easy way to put your project in terms that, you know, your grandmother can understand, which is the goal, right? Not always. Sometimes there is a more professional setting, and this venue, I think, is a combination of those, right? Certainly they need to learn to make things accessible, and they also are working on professionalization and operating at a particular level. But you're absolutely correct. And that's why we have a template at ARCS that is available to all of the co-Is. They can give it to their fellows, and they can create a very quick 2-slide, you know, elevator pitch to grandma. And so she will understand. So I encourage you all to take advantage of that. That's good practice.
Yeah, that's an excellent point. Yeah, because normally, normally you just need to use more like generic language to explain your technical perspective, right, to more audience, and then they can understand, especially like if your grandpa and grandmother, they can understand, and then that will be easy for others. Yeah. Casey, I know you are working this in the health area. Do you have any comments or suggestions for our fellows and associates? Okay, I have a quick question for this second presentation. That's great. So, because we're also working on one like user research projects. So, what are the challenges that you have right now for to conduct the interview? Like, how you recruit this audience, right? Reach out to these participants. They are willing to work with you and then to conduct the interview. Thank you.
We've had a really, really hard time actually collecting participants, and that's kind of been like the biggest barrier that we've faced. We started, I think we said in October, and it's been like really hard to get them. We've used flyers. We used an incentive of a $10 Amazon gift card. But a lot of the way that we've ended up getting people has been word of mouth, like people that we've known. Now we are doing a second year project, and we, email promotion, social media promotion. We have now reached out to our collaborators, Medtronic, and they're really like spearheading this next kind of recruitment stage, because we asked for help and we're very honest up front with like, this is an issue that we foresee. And they are helping us already with that. So it's definitely something that you need to think of before like we are even submitting our IRB, is how we're going to get people. We had a large problem with participant fraud, actually, I think is one that's really interesting to talk about. Very early on in our interviews, we noticed that people were pretending, like the same person was pretending to be this different people to get multiple gift cards. And so then we had to do a whole new IRB submission, and it just was like a problem that we did not foresee, that would not have existed were it not for the COVID-19 pandemic. And we have some pro tips now that we've done that IRB submission and worked with them very closely to like see how to like counteract that fraudulent participation. But yeah, I would just be very careful with how you, I don't know how to make this like cohesive advice, but stay on like ahead of it, like start before you think that you need to, and just be aware that like that you maybe need to put in checks for fraudulent participants as well if you are doing it via Zoom.
It's something that'll be written into your IRB. And I think we're starting to see that things do pick up. After I've spoken in several classrooms, our associates have spoken in classrooms, our fellows have spoken in classrooms, the departments have put the information out there and put our flyer out there. But flyering is difficult when students are not in session, right? We were particularly targeting relationships to the CSUN community, and whenever possible. And so, you know, that was an issue. But I think now it's picking up, and I think you'll have a much easier time of it now that class is in session and people are here. If you start in the summer, that's a red flag. Unfortunately, that was our dilemma, right? Was starting in the summer with our participant collection. So.
Okay, great. Yeah, thank you for sharing all this experience. It's really helpful. Any comments from our staff like Sarah, Stephanie, or Christina to add?
I would probably just add that I know that if any of the students could just share any of the value that they found working with people across different disciplines, different majors, as they did their research.
I'm sorry, was the question you wanted to discuss the value of the convergence of various disciplines?
Exactly.
Sure, would the students like to take that?
Sure, I'll start a little bit. Yeah, I've had a absolutely great time, you know, and it's been a very welcome break from, you know, all STEM coursework, and, you know, just really interesting to learn about, you know, something that I'd pretty much not known a lot about before, and now I know, you know, pretty good amount now. And so, yeah, incredibly interesting, a great brain break, if not, you know, just enjoyable to learn all that. And yeah, just past that, it also just helps, you know. Oh, I'm sorry, Samira, I meant engineering. And so, yeah, just basically amazing to learn about something else, and also just to, you know, bring it into your own field and remember that, you know, if you can find themes here, you can find themes in your own work. And yeah, I think that's it.
You know, a quick word about Stephen. Stephen is our community college student. When he came to us, he was right out of high school. He's been extraordinary. He's a mechanical engineering major. His goal is to come to CSUN and continue on this project, which stands to, you know, go some years. And at the end of the day, you've got this young man studying mechanical engineering, achieving at a very high level academically and all of that coursework. And he'll come to that with ethnographic training. He'll know how to conduct research, you know, using ethnographic methods. Dr. Ho can attest to the value of that as a mechanical engineer. And I just think, you know, it can only help. So that would be one benefit.
Thank you, Kevin.
Thank you. Yeah, excellent point. Before we end our seminar, I'm going to promote this next event. I think on March 18th, our bi-weekly seminar we will invite a special guest, is Dr. Patrick. She will be in CSUN in person in the ARCS crop space. So I highly recommend you to sign up on the RSVP to come in person to have a conversation with her, because the presentation will be from 10 to 11, and then we will have another in-person event with have further discussion, conversation with Dr. Patrick about the supervisable like education and training. And she, if you look at her portfolio right now, she is the director of California Office of STEM Engagement at the Ames Research Center and the Armstrong Flight Research Center. She was the director, the program lead for NASA's Minority University Research Education Projects, the MIRAP. So this one, she has been working in NASA over, I think it's almost 18 years. So that will be a really good opportunity for all of us, including the faculty and students, to learn more about like a minority, you know, the research and education, and how to engage with STEM. So I highly recommend you to sign up on the RSVP and then come to ARCS crop space in person. And then we have the further, you know, conversations with Dr. Patrick. Thank you. Oh yeah, we will have a great lunch preparation as well. Food will be provided. So free food, free beverage. Thank you. That's it for today's bi-weekly meeting. Thank you so much for all your coming in person and virtually. Thank you so much again.
Thank you, everybody.
Thank you.
Bye.
Thank you.
Have a good week.